continuing with Unit 10, Day 3, we're going to focus on some operations with rational expressions now. So operations with fractions. And we're going to focus on multiplying and dividing those fractions, those rational expressions. Okay? So remember, to multiply or divide fractions, we do not need a common denominator. And when we multiply, we just go straight across. All right? So just like we did when we simplified last time, steps to do this: we're going to factor everything we can. We're going to find restrictions by setting that denominator, saying it can't equal 0, and then divide out any common factors. Okay? So when we work with multiplication, we can cancel or divide things out. We can go vertically and diagonally. Okay, so if we're going to cancel, we can cancel vertically and diagonally. We can't cancel horizontally, okay, but we can go vertically and diagonally. Now, as we work with these, right, this first one, just a review, right, with fractions. So when we multiply, we just go straight across. So this is going to be 1 times 3 times 6 over 4 times 5 times 5. Okay, so 1 times 3 is 3 times 6 is 18 over 4 times 5 is 20 times 5 is 100. And then again, once we get that, we look to see what we can cancel out. So if we look 18 and 100, we can say we can divide those by 2. So we can cancel that to a 9 and a 50. So we get 9 over 50 for our simplified thing. And then here, since there are no variables in the denominator, since there's no variables in the bottom, that means that there's no restrictions. Okay, there's no way it's going to be 0 because they're all just numbers. There's no variables that could mess it up. So that's what we're working with here. Okay, so now in number 2, there's nothing to factor here, right? So what we can think about then is we can say this is 3RS times 8S over 40 times 15R. Okay, so restrictions, the only thing that has a variable attached to it is that 15R. So that thing cannot equal 0. So if we divide out that 15, R cannot be 0 is our only restriction there, okay? So as we look at this, right, we can start canceling stuff out now, or we can multiply stuff together. It doesn't really matter. So let's say we go ahead and multiply. So we take 3 times 8 is 24, and then we've got an R, and then we take S times S is S squared over 40 times 15, I think is 600 R, okay? So now we look to see what can we cancel out of this thing. So first of all, we got an R that we can get rid of, okay? And then 24 and 600, what can we divide out of those two? So we can actually, 24 goes into both of those. So we can divide out of 24. 600 divided by 24 is 25. So what we've got left here is we got 1 and then S squared. So S squared over 25. With the restriction, R cannot be 0. Okay, so that's what we're working with. Now, in one like number 3, right, this one's factored for us already. So we can look at restrictions right away. So we got a bunch of restrictions here. We got 1, 2, 3, 4 things, right? So we got 2x cannot be 0. X plus 2 cannot be 0. X minus 1 cannot be 0. And x plus 1 cannot be 0. So this guy gives us 0. This one, negative 2. This one, 1. And this one, negative 1, right? So we get 0, 2, and then positive 1 and negative 1 for our restrictions, right? So now what we can do, again, is we can cancel, since it's all factored, we can cancel vertically and we can cancel diagonally, okay? So if we look at this first fraction, boom, x plus 2, gone. If we look at the second fraction, if we look vertically, there's nothing we can work with there. Okay, so let's look diagonally. If we look diagonally, we've got an x minus 1 and an x minus 1 diagonally. And then we got a 2 and a 6. We could divide those out to make that a 3. And then we've got an x squared would get rid of one of those x's. So we just have x to the first power. So if we look at the numerator, we've got a 3, we got an x, and we've got an x plus 4. And then in the denominator, we've got x plus 1. So our answer then, we've got 3x times x plus 4 over x plus 1. Okay? And then that's what we're working with. Now, for number 4, right, this one is not factored for us, so we're going to have to factor it, right, especially in order to find restrictions. So this guy, big X, multiplies a 3, adds to 4, would be a 3 and a 1. And then, so that would give us r plus 3, r plus 1. And then this guy multiplies to 6, adds to 5, would be 3 and 2. So r plus 3, r plus 2, times 1 over r plus 2. So restrictions, r plus 3 cannot be 0, r plus 2 cannot be 0, and then those guys are the same thing, right? So we don't need to put it twice, so just these two to worry about. So subtract 3, subtract 2, so r cannot be negative 3 or negative 2, okay? And then if we look to cancel vertically, we can get rid of those. And then diagonally, nothing, right? So what we've got here, r plus 1 times 1 is just r plus 1 over, in the bottom, r plus 2 times r plus 2, right? And you can write it like that, or another way you can write that would be r plus 1 over r plus 2 squared. Okay, so either one of those is fine with me, whichever way you want to write it, all right? So that's how we're going to multiply, okay? That's what we're working with. Now, division, okay? When we divide fractions, okay, remember what we do is we turn it into a multiplication problem. So we multiply by the reciprocal when we divide fractions, right? So just like we did before, factor everything you can. Find restrictions. We're not going to worry about restrictions here. Okay, and then it says keep the first fraction, change the division to multiplication, and flip the second fraction. So that's where that reciprocal comes in. Check for new restrictions, but again, we're not going to worry about restrictions. And then divide out any common factors. So here it says directions, divide, assume all variables are defined. So when you see this right here, okay, that means we don't need to find restrictions. Okay, so when you see that phrase in the directions, that means you don't need to find the restriction. So what we're looking at here in number 5, we have 6/5 divided by 9/10. So again, just review of fractions here. So nothing to factor. So we keep the first, change that multiplication to division, and then flip the second. Okay? And then now it's a multiplication problem. So we can cancel vertically or diagonally, or you could multiply, whichever way you want to do, right? So if we just multiply, that would give us 60 over 45 going straight across. And then we can divide out a 15 out of both of those. So that'll leave us with 3 and 4. So we're left with 4/3. Okay? Or if you want to, again, cancel diagonally, what you could do is if we take this, right, and we look, can't do anything vertically, but diagonally, we can take 5, goes into 10 twice. And then 3 goes into 6, and 9 goes into 6 twice, into 9 3 times. So what we'd be left with would be 2 times 2 over 1 times 3, which is 4 over 3. So you get the same thing, okay? Either way you want to do it, all right? Now, we start throwing some variables in here. That doesn't change anything, okay? So we still keep the first, change the multiplication, and flip the second, okay? And then again, you can multiply if you want, or you can cancel diagonally. If we multiply, we'd have xy over x squared, y squared. And then we can look to cancel out. So x would get rid of that square, right? It'd just be x to the first power, and then y would get rid of that square, so it would be y to the first power. And then on top, we just have a 1. So it'd be 1 over xy. That's what we would get there. All right? And then in number 7, okay, partially factored for us. First fraction is factored, second one is not. So let's factor this second one. So in the top, multiplies to -2 and adds to -1 would be -2 and +1. And then in the bottom, we would do multiplies to -2 and adds to +1 would be +2 and -1. So close to the same thing. So this guy would be w minus 2 and then w plus 1. And then this one would be w plus 2, w minus 1. Okay? So now let's again keep the first. So w plus 2, w minus 2 over w plus 1, w minus 1. Change it to multiplication and then flip the second. So this guy now becomes the numerator. And then this one becomes the denominator. Okay, and then again, you can multiply it straight out, right? Put it all in one fraction. You can go vertically or diagonally, whichever way. Okay, so vertically, nothing we can do, but diagonally, if we look, we've got w minus 2, and we've got w minus 1, and then that's it. So what we're left with, w plus 2 times w plus 2 over w plus 1 times w plus 1. And then again, you could write it that way, or you could say that's just w plus 2 squared over w plus 1 squared. Okay, either way you want to write it, perfectly fine. Okay. And then number 8, a little bit of multiplication and division, a lot of factoring in this one. Okay. So if we look at this first fraction, so let's see, multiplies a 3 adds to 4 would be a 3 and a 1. So that would give us r plus 3, r plus 1. And then this guy multiplies a 6 adds to 5 would be 3 and 2. So over r plus 3 times r plus 2. And then this is multiplication, so we don't flip anything. Okay, and then we've got this guy, so factor multiplies a 4 adds to 4 would be a 2 and a 2. So r plus 2, r plus 2. But we've got division here. So we got to flip, right? So change it to multiplication, keep the stuff in front, change the multiplication, and then flip so that r plus 5 becomes the bottom. And we got r plus 2 on the top now. Okay, so vertically, if we look, we can get rid of those r plus 3s. Nothing in the second fraction, nothing in the third fraction vertically. Then diagonally, if we look, we can go r plus 2, and then we can also say, well, there's r plus 2 there. So all we're left with is r plus 1 over r plus 5. Okay, so that's what we're working with, multiplying and dividing these rational expressions, okay? So try out that homework. Let us know if you have any questions.